Hello and welcome to the MasseyHacks 7 closing ceremony. First of all, congratulations to everyone who participated in MasseyHacks 7. We hope that you were able to learn something new and create something amazing. Now, before we begin, we'd just like to thank our sponsors again, because without them, this event would not be possible. First up, we have our gold sponsor, Connecting Windsor-Essex. They actually have a short message that they'd like to tell you.
Hi there. My name is Dan Cercelli, and I'm President and Chief Executive Officer for Connecting Windsor-Essex. And I'd like to begin by saying thank you to Vincent Massey Secondary School and everyone involved in the 7-week challenge for providing us the opportunity to participate and share a little bit of our story. So, Connecting Windsor-Essex, and you probably didn't know this, but we've actually been around for over 25 years, and our key responsibility is to supply high-speed quality connectivity to every single secondary school, elementary school, the city of Windsor, the county of Essex, all of the libraries throughout Essex, as well as the university and the college. So we provide connectivity to every one of those facilities. And we use a variety of technologies to provide that connectivity. So we have fiber throughout the greater majority of every one of them, but we also have some point-to-point connectivity. We also have some coax connectivity, and we also have some cellular services that we supply and broker for every one of those organizations. And the great thing about that is out of these organizations, I get to work with some of the most talented technologists in the region of Windsor-Essex. And we meet on a regular basis. Every month we meet, and we're always talking about what can we be doing to improve our connectivity, our network infrastructure? What can we be doing to improve access to that network? Of course, what do we need to be doing to make sure we keep that network very secure? Because what we connect, we have to protect. And also, how are we keeping people informed? How are we keeping people educated on the importance of privacy, keeping your data secure? So every month we meet and we talk about these topics for this reason. We know that essentially this connectivity, broadband, that's the underlying infrastructure to where everything else happens. And we know we have to continue to build out this underlying infrastructure, because when we build out that infrastructure, that's when application development begins. And this is what we know is important. The infrastructure is very valuable. We recognize that value, but really what's important is building our digital community. And this 7-week challenge is a perfect example of a new digital community. So for everyone participating in the 7-week challenge, my hope is that you learn something new, you improve your skill, you've developed another way to look at a problem and solve a problem. And really, I really hope that you've met someone new that you probably would have never met had it not been for this digital community. So with that in mind, I'm going to end right where I started, and I want to say thank you again to Vincent Massey Secondary School for inviting us to participate, for all of the people who contributed all kinds of time to coordinate, to organize, to follow up and communicate with everyone involved and organizations like myself. We thank you very much for that effort, and we're really grateful to have been a part of this. Thank you very much, and best of luck to everyone participating. Have a great day.
Now, on to our silver sponsors. Thank you to We Tech Alliance, the University of Windsor Students Alliance, and St. Clair College. And finally, we have our bronze sponsors, the WFCU, the GEC DSB, the IEEE Windsor section, Genda XYZ, Echo AR, Weglot, and DigitalOcean. Now, we'd like to show you a few video demos of projects that the judges really liked.
Only recently has mental health received the attention it deserves, but services are still lacking. A third of Canadians that need mental health care aren't getting it, and wait times can be as long as 6 months to a year. Talk With Me is a glimpse into the future. Built on the world's most advanced AI language model and state-of-the-art voice recognition and speech generation technology, Talk With Me erases the border to mental health services. Here's how it works. Add your name and choose a therapist. The AI is able to learn your name and will use it in conversation. Choose from a variety of topics or keep the conversation open. Now simply talk. Talk with me makes it feel like you're on the phone. The virtual therapist is able to come up with unique approaches to your problems. It's really that simple. While our team was super excited to see the results we did, there is still a lot of work to be done before this is ready for the public. But we believe this is the future. It demonstrates the power and possibility of technology. I'll leave you with a conversation we had with the AI that completely blew our minds. My girlfriend is ignoring me.
Would you like to talk about that?
Yes.
I know this can be an issue for people. What have you tried so far?
I haven't talked to her about it yet.
So why have you been ignoring your girlfriend?
She's ignoring me.
I could have told you that, but ignoring someone when you're feeling ignored just makes matters worse.
I see what you mean.
Do you feel that all of your efforts to keep the relationship going have been futile?
It seems like whenever I try and talk to her, she doesn't want to talk to me.
I do see that you've been working really hard, but what's the situation like on the other side?
I don't know.
If you don't know how she's feeling, then you can't really know if you're doing all you can you?
During this time of social distancing and pandemic, there's been a growing apathy to exercise at home with energy and intensity. We face this problem ourselves. Most of us are often stuck with electronic devices and reluctant to even move a body part. In the long and short term, this will adversely affect our mental health. Introducing Avasta. So, how does Avasta work? The user will create a room with their own specifications. Players can join said room with 6 digit code. Players are given a pose to imitate, and our ML model will judge their accuracy and ward points in real time. After time is up, final scores are given and uploaded to the leaderboard. Now, the languages and platforms we used are HTML, CSS, and JavaScript for the front end, Python and Flask for the back end, ML5 plus P5.js for training and creating the model, Firebase where we use file storage record session info such as points and room code, Twilio for webcam feeds, and UIUD for code generation and validation. You can find more info about this on our dev post. Now, on to our demo. With everything, there's always room for improvement. This goes for Avasta as well. Our future plans include more poses. We hope to add more images for our model, more people, up to 10 people per room, more game modes. We plan to add more game modes. And overall, we're excited about the future. Thank you for your time. This is the Avasa team signing out.
1 in 5 people will develop melanoma in their lives. Early detection is crucial, as the survivability goes from 99% all the way down to a mere 27% as time progresses. The problem? Early stages of melanoma can only be diagnosed through biopsy. This means if you wanted to check a lesion or a mole, you would have to get a piece of it removed and sent to a lab. Since we all have moles, any one of them could be melanoma or a skin cancer, and we would never know until it's too late. If only we had an intermediary test, a test we could do at home and get informed about potentially risky lesions. Metaskin is a web-based skin cancer detection service that allows anyone to accurately test for melanoma in the comfort of their own home without a biopsy. First, users take a portrait. We use a unit segmentation model to segment out their skin and estimate skin color, a key risk factor. The American Cancer Society notes that melanoma is 20 times more common in Caucasians than in African Americans. Next, common patient information is input to tabular models such as gender, age, and lesion location. Finally, an image of the lesion or mole itself is inputted. After processing, users are given risk factors for melanoma and courses of action. Our outputs are not limited to melanoma in particular, but a plethora of other skin conditions: nevus, keratosis, lentigo, cafe au lait macule, or atypical melanocytic proliferation. Some of these are precancers, others common conditions confused with skin cancer.
So what makes this all possible? The core of Metaskin isn't some AutoML model, but rather 6 ensembled PyTorch models trained on 2 datasets by the International Skin Imaging Collaboration, totaling 200 gigabytes on 8 NVIDIA Tesla V100 GPUs, using techniques from a Harvard paper. We optimized the models in the paper for inference latency, with about 93% of the performance and 6 times the speed. We also introduced a new innovation in this hackathon, a new metric called weighted area under curve, towards eliminating false negatives. In our domain, false negatives are detrimental, as it implies missing a diagnosis of a life-threatening condition, especially with melanoma, given the rate at which survivability decreases as time progresses. On the contrary, predicting false positives just means an extra trip to the family doctor. As such, we minimize the false negativity rate and achieve a false negativity rate for melanoma of just about 6%, a mere 2% behind biopsy. Existing accurate commercial implementations use 2 models and cost an astounding $10 per image, a result of the compute required and the difficulty of scaling on GPUs. We solve this with distributed computing. Using the distributed compute protocol as our inference platform, we can provide free scans with more accurate models. Anyone can donate their spare compute power through a website and WebAssembly with minimal cost associated. Metaskin brings skin cancer diagnosis away from invasive methods and towards home diagnosis, an important step to reduce fear and increase adoption for the most time-dependent cancers. Thank you.
When the COVID-19 pandemic started, millions of older people that depended on caretakers had to risk their health due to increased exposure to COVID-19. After all, what choice did they have? They needed their caretakers to facilitate their needs, even if it meant potentially being exposed to the deadly COVID-19 disease. This is why I created a personal robot assistant capable of being controlled by simple eye movements and blinks. Age brings many problems to the body, including the loss of ability to move due to bone and muscle degradation or paralysis. However, the eyes seem to be one of the least affected body parts by age, and any damage to the eyes can often be fixed thanks to modern technology. Additionally, since eye movements are easily controllable, I decided to use eye tracking as the way of controlling the robot. To implement the eye tracking, I used the DLib machine learning model to locate the major facial landmarks. Taking the landmarks that surround the eye, I was able to produce a mask of the eye area and then create an algorithm to extract the pupil of each eye. Additionally, I was able to ascertain when the user blinked using the position of the eye landmarks. When the user starts the application, an initial calibration is done to match the user's gaze with the actual directions that can be used to control the robot. After the calibration is finished, the user can begin to control the robot. There are 4 main controls. The first is drive, which is powered by 2 large servo motors and enables the robot to move in all 4 directions. The second is rotate, which is powered by 1 medium servo motor and enables the robot to rotate the crane. The third is raise or lower, which is powered by 1 DC gearbox motor and enables the robot to raise or lower the arm. Finally, the fourth is open or close, which is also powered by 1 DC gearbox motor and enables the robot to open or close the claw. A EV3 brick was used to control the servo motors, and a Jetson Nano was used to control the DC gearbox motors. Additionally, a Raspberry Pi V2 camera was connected to the Jetson Nano to relay what the robot sees back to the user. Here's the demo of the robot in action.
Okay, that's it for demos. Congratulations and great job to all the teams who the judges decided to feature. Now on to prizes. All right, so first up we have our activity prize winners. The winner of the AirTag or Tile Tracker raffle is Evan S. Congratulations. And the winner of our TP-Link Smart Plug raffle is Seth G. As for our Minecraft build tournament, congratulations to Ali M, who built this wonderful desert paradise. They'll be walking home with a $20 Amazon gift card. Now on to our category prizes. Congratulations to Ogme for winning the Echo AR category prize. They'll be getting a $50 Amazon gift card as well as 1 month free business tier access to Echo AR's platform. Next up, we have our best beginner prize, and that goes to Mongo. Congratulations. They'll be getting an Amazon Echo Dot as well as $125 in DigitalOcean credit. Next up, congratulations to the winner of our best lifestyle hack, Sarang G, for their A Personal Robot Assistant controlled with eye tracking. They'll be getting a Ubico security key. Next, congratulations to DMojBot for winning the best education or learning hack. They're getting a set of Muji pens and notebooks, some of the very best writing utensils in my opinion, as well as $125 in DigitalOcean credit. For the best health and well-being prize, congratulations to Flo. They're getting TileMate trackers, MasseyHacks mugs, and of course mason jars for all their canning needs. And finally, for our Hacker's Choice prize, coming in at 18 votes, congratulations to J Property. They're walking home with a $30 Amazon gift card. Next up, we have what you guys have all been waiting for, the winners of the overall prizes. Now I say prizes because the judges had a really hard time choosing just one, so they chose two. First up, congratulations to Avasta for winning the Judges' Choice Award. Avasta is a neat concept for doing workshops with your friends remotely. The judges were impressed by the easy-to-use interface and the creative use of machine learning and computer vision. And now for the best overall prize, congratulations to Metaskin. They trained an ML model using data from the International Skin Image Collaboration to perform an optical cancer diagnosis for an affordable price. The product was notable for using data from a research paper and successfully implementing it in a clean interface. The judges liked the fact that the model was self-trained as opposed to pre-trained as well. So that just leaves the question, who is going to Pinnacle? Well, the judges chose two teams to represent MasseyHacks at Pinnacle this September in Dallas. And those teams are Metaskin, congratulations to Stanley, Neural, and Siebert, and Personal Robot Assistant controlled with eye tracking, congratulations to Sarang. So again, they'll be representing MasseyHacks at the Pinnacle Hackathon this September in Dallas. Congratulations and good luck. So that's it for MasseyHacks 7. Thank you to everyone who participated, our hackers, our mentors, workshop hosts, and judges, and of course our sponsors, as well as the rest of the organizing team for putting this together. We hope you had a great weekend learning something new and doing something cool, and hope to see you next year.